Hello everyone, Mrs. Hamby. Just here we're doing vertex form again, but today we're going to be focusing on this A part. So if the A is a positive, what does that do to the graph? If the A is a negative number, what does that do to the graph? Also, if we're given a actual number like 4 versus a 1/2, what is going to change about the graph? Okay. All right, so here we go, still standard form and intercept form. Same exact essential question and our I can statement. All right, so if you take any shape, you can transform it. So if you have a square, you can stretch it and you can compress it. Same thing with a triangle. You can stretch it out and you can make it shrink or compress it. So that's what we're going to be doing with our quadratics today. Here is the parent function of a quadratic. That's when it has a 1 in front. But what happens if we have a number big like 9? What does that do to the graph? You can see right here, it stretches it. And so we call this a vertical stretch. But it doesn't really matter. You just need to make sure you know it's stretched. Versus here, we have a fraction. So I like to say fractions make it fat. Fractions make it fat. So this is a vertical compression. I also call it a vertical shrink too. So it means the same exact thing. All right, here we go. Same exact steps. So no need to rewrite these. Hopefully you're just continuing your notes on the same page of the last one. Oh, that's an awful color. So just continue your notes on same notes as before. All right, moving right along. And so just to refresh your memory of the parent function. So remember, we put x in the middle. We like to plug in our reference points. Then you do -2 squared, we get 4. So remember, I call these our reference points. And so plug in -1 squared gives us 1, so on and so forth. Hopefully I don't have to do that again, but hopefully you guys realize that. And here we know our vertex is going to be at 0, 0. And since there is a 1 in front, it's positive. It's going to actually be the minimum because we're going to open up. All right, so we're going to go 0, 0 over 2, right 4. Or sorry, right 2, up 4. 1, 2, 3, 4. Left 1, up 1. Left 2, up 4. 1, 2, 3, 4. And if you wanted to, you could put in 3. And we'd get 3 squared, which is 9. So you'd go over 3, up 9. We know it goes off the graph, but we get the idea. Okay, so missed that one, but that's all right. So that's just referencing that parent function, just to remember that. All right, so what we're going to do is we're going to be taking this thing, and we know that the A part, that's the number in front here, that's your A, is going to affect our graph. And so what we're going to do is we're going to take this thing and we're going to take all of our reference points here and we're going to multiply them by 3. So we're going to take our reference points and we're going to multiply them by 3. And then we'll have a new vertex. Well, actually not the new vertex on this. So we could look at our h and our k. Hopefully you realize there is not a number inside with the x, because then it would be like this, x minus 0 squared, and plus we have a 0 at the end, plus 0. Okay, so our vertex is going to be still at 0, 0. Notice the A is also positive. Since that A is a positive 3, we know it's going to be a U that opens up. All right, so we're going to take those same reference points. We should have them memorized by now. Same thing, we're going to be 4, 1, 0, 1, 4. The only difference now is we're going to take that, all of them, and multiply it by 3. So it's going to be 3 times your y, which was 4. So now we get 12. It's going to be 3 times your 1, and we're going to get 3. So it's basically taking all of these and it's stretching it by 3. And we could do that all the way down. And we're going to take that 1, 0, 1, and 4. So we're taking the y values and we're stretching them by 3. Okay? All right, so we're going to get 0, 3, and 12. So obviously our graph only goes to 6, so it's going to be really hard to see the 12, but we're just going to make it work. So we're still going to go at 0, 0. Instead of going left 1, up 1, we're going to go left 1, up 3. Stretch it up by 3. We're going to go right 1, up 3. Stretch that number by 3, because usually it was at 1, 1, 1, but now we're taking it and stretching it by 3. And we're going to just say 212 is way up here at the very, very top because we ran out of room. And so we are going to have a parabola that is super skinny. That's what that 3 does. Oh, no. That's what that 3 does, is it takes this thing, it stretches it out and makes it nice and skinny. All right, let's see what we have next. All right, so I'll do this one as well. And notice the A. The A is dividing by 4. So we want to be a little bit pickier on our numbers that we plug in, because we want to be able to divide those numbers by 4. We're still going to pick our favorite 0, 0, because our H is 0, our K is 0. And so that one is easy. You do 1/4 times your 0, which we know is just 0. And typically, we would go left 1, up 1, but instead, we're going to go ahead, I'm just going to write all of these. We're going to go ahead and take it and multiply it by 1. So this basically just says 1 divided by 4 is just 1/4. So instead of going right 1, up 1, we're going to go right 1, up 1/4. I'm going to say that's about right here. If this is a half, then that's 1/4. And it's going to be the mirror image. So if we do +1, it's still going to be 1/4. And you could just do big dots about that area. All right, so what if we go -2? We know normally it would be at 4, but we got to take that thing and times it by 4. So it's literally 4 divided by 4 is just 1. Same thing with the +2. Remember, these are your reference points. And so it's going to be 1. So basically that means you're going to go right 2 and only up 1. Left 2 and only up 1. So it's actually making it a really fat parabola. And so if you wanted to see 3, we would have a fraction. But so let's do 4, because 4 will come out nicely. So I know there's writing here, but let's do 4. If we squared 4, that's going to be 16, right? 4 squared is 16. And so if we go right to 4, square 16, and then you're going to take that number and times it by 1/4, and 16 divided by 4 is just 4. Same thing's going to happen if we did -4. We would have 16 here, and we would get +4. So if we go right 4, we would go up to 4. Left 4, we would go up to 4. Not really necessary to do those points because you kind of have an idea of it, but it's kind of nice to have a little bit more. So you can see that it is going to be a parabola that is a little bit fatter than normal. Oops, I missed it. Just make it bigger. Okay. So that is what happens to your graph if you multiply it by a quarter. It's going to shrink your graph. All right, so go ahead and let's have you guys try this one. Give it a try. And in the next video, You can watch to see if you did it right.